Hello everyone. So my name is Mahmoud Mubarak. I'm head of tech for Egypt Tech Center. It's about 1 year here with Egypt, and we launched, as you see, our first tech center in Africa. Of course, after Proto Tech Center, in only maybe less than 1 year. I'll try to be very quick because we are about it. So first of all, welcome everyone, and thank you for all just to accept our invitation to have such a quick discussion about the technology here. اوكي سو الاول انا عايز اتكلم بالعربي علشان اغلبنا برضو عرب صح سو ويلكم بيك يعني اهلا بيكم هنا انا برضو بتكلم انجليزي انا اسف فاهلا بيكم هنا وانا مبسوط جدا ان احنا ابتدينا اول تك ميت اب هنا في القاهره بالنسبه لافريقيا وان شاء الله تبقى ديسكشن كويسه وتبقى very interactive. So we are all thinking about changing people's life here in Africa, and we have our first and most important value from the 12 values here in Jumia, which is we wake up every morning because we share a common purpose that we change people's life through the internet. So that's why while we are building the new Jumia Tech Center, we're keen about having discussions with the tech community, okay? And more to share what's behind the scenes in Jumia and providing solutions while we have the operation in 11 countries. So this meetup is to be dedicated to explore several exciting challenges we have faced and how to leverage our experience to build a scalable product. أتمنى إن هي تبقى very interactive وأتمنى إن هي تبقى مثمرة جدا لكلنا يعني. احنا طبعا عندنا هنا الناس اللي في بورتو تك سنتر عدد كويس من التك سنتر اللي موجود في اوروبا طبعا وهنا احنا حوالي وصلنا ل 140 just only less than 1 year فده عدد كويس الحمد لله يعني حققنا انجاز كويس في خلال سنه. Okay, so we will have our first session, Search at Jumia by Bruno Aguiar, Director of Engineering for marketplace platform. It will be about 1 hour. So Bruno Aguiar. Bruno has 10 years of experience, 6 years in Jumia and 4 years as a software researcher. And he kicked off more than 10 systems in Jumia, like mobile, logistics, finance, customer experience at early beginning, and search, like the topic that he will be talking about. So Bruno will talk about why Jumia built its own fine-tuned search solution and how it was built with scalability and adaptability in mind, and what are the technologies powering it. Please join me welcoming Bruno Aguiar, Director of Engineering for Marketplace.
Thank you everyone, good evening. Can everyone hear me in the back? All good? Thank you. So, for the first session, I will try to give you hopefully a nice overview of what we have done for search here at Jumia. So we will start with the context. I would like to try to give you an overview of the sizing, of the scale in which we are working, and also of the context that we consider for product discovery or search in general. Give you a quick overview of the journey of what we have been doing here at Jumia on the topic. Then we will do a deep dive into the technical part of it. And then finally present some results, hopefully some good ones. And if we still have some time, we will cover up some of the most important next steps that we have already identified. So first of all, starting with the scope of search. It's not only about text search, which is the most immediate things that comes to mind. It also includes, for example, the navigation. So when you're browsing around on the site, filtering by category, or using any kind of the other filters that generally appear on the website, filtering by price, by brand, all of that is eventually product discovery. It's a search under our scope. Then we have naturally the textual search, the most typical one. Which can be combined with the other parts of the navigation, so we can use the text search, still apply some of the filters. And then we also have a couple more functionalities, use cases to try to enhance the search experience. One of them is the autocomplete features, in which we try to guide the user through the product discovery experience. And then we also have the recommendations that we try to compute. So we have user-level recommendations that we try to compute at a personalized level for every customer at Jumia. But then we also have the product-level recommendations, the bought together, the viewed together, and that kind of stuff. So now in terms of scale of what we're doing, does anyone want to try to guess how many products we have at the moment available in Egypt? Wild guess? 10,000? A little bit more than that. And across all countries that we have at Jumia. 40 million? Getting close. So, as we can see, we have more than 60 million products in Jumia across all countries currently available for purchase. So with stock, with availability. This translates into more than 10 million product updates every day. So price changes, content updates, all of that. So it's already a quite considerable scale that we are working at. More specifically for Egypt, we have at the moment more than 3 million products available on the website. All these products are split around 35,000 categories that we have. This is using the classic category structure, a tree-like structure, for all of these categories, in which we try to catalog all the products that we have. And then we also have 128,000 brands across all the products that we have available. Now in terms of traffic, on a normal day, we generally reach more than 35,000 requests per minute that we are doing, so including all the use cases that I described before. But then, as any e-commerce platform, we do have our big events or big campaigns. Here at Jumia, that's clearly the Black Friday and the Jumia anniversary. Those are the biggest campaigns that we have. And in such campaigns, we can easily multiply this by 10. And then our maximum record was actually 1 million requests per minute across all countries at the same time. And here we also have an interesting challenge, as you can see on this chart. So this is a random chart I took from some of the campaigns. And you can see here the requests per minute. And when the campaigns appear, it's a very drastic increase that we have. So when we have flash sales, it's very immediate. Like people all come at the same time, so we have a very big peak for that campaign, which also comes with some challenges. So now a little bit about the journey, the evolution of search at Jumia. In the beginning of 2019, we were using Algolia. Quick show of hands, does anyone know Algolia? Okay, a couple of people. So it's a search as a service, not a bad one, actually. It's pretty good to kickstart the search interest of any company. But then for us, we rapidly found some limitations in terms of lack of flexibility, according to some stuff that we wanted to do, but specifically in terms of scaling. And this is something recurring here at Jumia. Due to our scale, if we start using these services, we often will hit some kind of problem in which they cannot handle the scale that we have, the campaigns that we have, and then we will need to internalize that technology and build it ourselves, basically. So that was already one of the problems, the tooling. We knew that we would need to build something, but then there were more issues or more challenges that we wanted to solve, since we were now going to start the project in Bruno. One of them was the lack of feedback loop in terms of analytics. So there was here no actually automatic feedback from analytics for decision making about what should be the formula for ranking and that kind of stuff. And neither can we reach the assortment. So we didn't know actually which were the products that were selling the most, so that then we could actually consider that into the ranking. Another of the issues was the very low engagement that we had in terms of experimentation. So we can only improve if you experiment new things and see some results on it. and that was actually not happening at the time. And due to that as well, any problem that we found on the search, we would actually fix it manually using full page redirect. Since we had very low flexibility in the tool, we were basically fixing the problems outside of the search and doing it all manually. So we, according to all those challenges, we identified some of the key goals that we had for the project. And one of them was clearly the scalability. So we wanted to be able to handle the growth of Jumia. So not only the scale that we had at that time, but we know that it's Jumia, it's going to grow. So we will need here to have a scalable solution, both in terms of assortment and in terms of traffic. So we know that both these things will grow over time here at Jumia. Then the other one was the experimentation, which not only we want to start it, but we want to make sure that the lead time for all these experiments is as low as possible. So there are many experiments and we can continuously improve the search experience. And for that, we would also need some real-time configuration so that actually we can have search engineers tweaking a little bit the formulas and all of that and doing the tests without any kind of development need from a technical team. Then we would also want to have flexibility to adding our own features, which was already being a problem, and especially trying to leverage the data that we have. And this is actually something transversal in Jumia, not only for search. We do have a lot of very useful data that we can actually start using more and more to give a better customer experience for everyone. So a little bit now on the development process. Similar to a lot of projects here in Jumia, we try to use the agile mindset and very quick prototyping. So we were able to build a very simple, literally an MVP, the minimum thing that we could deploy in 3 months. It only contained the navigation part, not the full set of features, and we deployed it as soon as possible in one of the smaller countries in which we operate, and then continuously through iterations we were adding more features and collecting the feedback from having the product live. So then we went with text search, with the multiple languages, with fuzzy search, with the recommendations. All those features came iteratively here, and through that we were also rolling out into bigger and bigger countries. So this process took around 7 months since we decided that we wanted to do this until we actually shut down the contract with Alpha and shifted entirely into this new system. And then since then we have been improving it further and further. So now a little bit as well on the mindset of this kind of things. First, we A/B test everything. So there is absolutely no change either of code or of configuration that is made into the search formula or anything else that is not A/B tested to make sure that it brings an improvement to the system. Then as well, in terms of continuous integration, continuous deployment, we have the standard practice of using feature flags. And here it was actually interesting that by enabling the activation or deactivation of feature flags with the A/B tests, we were able here to gain a lot of agility. So developers are never blocked. They do all the developments they want protected with feature flags, and then the search engineers can simply turn them on or off in the A/B test that they are doing and actually seeing if the developments are bringing any kind of improvements to the system. And then, well, this is not a classic roadmap project in the sense that it involves a lot of investigation, and it means that there is a lot of trial and error, and we quite often need to restart some new feature because the approach we were taking was not bringing any improvements. So a lot of trial and error here, a lot of investigation, a lot of focus on the data that now we are having from the analytics, and then also the big concern of scalability and quality. So as we saw, we can have very big promotions with very considerable peaks in traffic. So even if we have some features that will raise considerably the quality of the search, we also must consider the scalability part of it. So there is always here a compromise between the two. Now a little bit about the tech. Actually, we can start with the project naming, the justification we have for it. So the project is called Shrek, and it would stand for search and recommendations, since these two topics are very related and handled by the single system. This is a very simplified version of an overview of the system interactions. We can consider here this Jumia.com as being the website, the mobile apps, so any customer-facing software that we have, that our customers are actually using. And let's start with the creation flow. So our sellers are creating their products in another system. They eventually reach the shop part, the Jumia.com, which would then publish these products into a Kafka topic. So Kafka here is working as our event streaming platform and making sure mainly that Shrek is not overwhelmed with these updates. So as I said before, we have more than 10 million updates per day, but we do want to prioritize the searches. So by sending all of these events via Kafka stream, we make sure that we will consume these updates at a rate that will not be harmful for the search experience. So products would be sent to a Kafka, then the Shrek system would consume them and store them in an Elasticsearch cluster that we have that is gathering all the catalog data, all the products are then stored in an Elasticsearch database. If we now think about the search flow, so you take the app, you go to the website, and you make a search for an iPhone, for example, you will be sending a search request to the Shrek system, which will actually read the configuration from a Postgres database, so knowing which kind of A/B test is enabled, which should be the ranking for all those sorts of configurations that we can have. And from that, we would build the Elasticsearch request, do the request to the database, return the products, and show them on the system. Then there you would probably click it, add to cart, purchase it, or simply ignore it. All of those events are actually being sent to analytics, the impressions, the clicks, all of that being streamlined into a data lake, and this is where our data scientists can go wild and write all sorts of algorithms and have many sorts of computations from which we want to get some scores and recommendations, for example. So we will be computing here product level scores, which are once again sent to a Kafka stream, and Shrek will then be able to consume them as well. So this is how we basically close the loop with analytics information to feed back into the search experience. So a little bit more in terms of configuration. Once again, we are using the Postgres database with full auditing, and not only because we want to know who is doing the changes, but we want to have a full history of any kind of changes. So if we are using historical data and we saw a strange peak or downwards or upwards, we want to know which kind of configuration was enabled at that time. So it's very crucial for us. And we are using this Postgres database to enable the real-time configurations. So we then have a back office system showing all the configurations that are enabled, and the search engineers can simply come here and tweak around all the formulas and apply it in real time. So any development, the development team doesn't need to be involved for this. About the Shrek application, so it's a simple web server. We are using Spring Boot and developing it in Java. Its main function is working as a middleware between Elasticsearch and the website, but then it's where I also do all the handling of configurations via the database for the A/B tests, and then it's also basically the customizable layer that we have. So it's a place where we can work on and add new features on top of search. So this is adding our flexibility in terms of features. We have mainly two pipelines, one for updates and one for searches. So Shrek, in terms of updates, has two main jobs. So there are some scores that we are computing on the fly. As soon as we receive a product, we will do some calculations. A good example is the weighted average rating. So instead of simply using the rating to sort by rating, we actually do here some calculations to have an average value to make sure that products with a single review of 5 stars don't appear on top. So that kind of calculation can be done in real time on the Shrek application. But then another important part is actually merging the product information with the scores that are being computed from the data lake. And then we have the pipeline for requests. And as soon as a request comes in, the first thing we do is reading the current configurations. Actually, we are not reading them from the database. They are always kept in memory for performance reasons. So we don't want to make 1 million requests per minute to the database to get configurations. So we generally load them into memory for performance. Then we will create the Elasticsearch request according to the configurations we just read. And then we have this layer that we call the processors, when we can add additional features to work on top of it. So this is where we have then enough caching. We have several layers of caching according to the type of data. It's where we do some re-ranking. So it's we can here do a second swap around the products and re-rank them according to some specifications like seller quality. We also have the diversification and insights. So there are some searches in which we can say that we not only want to show the best products, but we want to diversify a little bit between two categories or two brands. And then we also have here the personalization, where we can get some information that we have from the user about what kind of categories he enjoys the most and he has been purchasing, and try to boost a little bit with those kinds of products. Then we have here Elasticsearch. Actually, quick show of hands, who has ever used Elasticsearch? Okay. Who knows about Elasticsearch? A lot. So this is also one of the factors why we are using Elasticsearch. It's widely popular, it has been growing considerably, so it's becoming more stable and better every year. Actually, even at Jumia, we already had some previous experiences with it. So it's very basically, it's a search and analytics engine. It's built on top of Lucene, and it's actually developed in Java. It's very fast. Overall, there are even some teams that use it as a caching layer for some other databases. It's distributed by nature, which will help us in our scalability topics. Elasticsearch has a very big concern on that as well. And it's already feature-rich in the sense that a lot of features are already there, but then it even allows us to write custom-made plugins to run on top of it. So it also gives a very good flexibility in terms of development. And then also, it's important to mention it's open source, which is also interesting. Even for debugging from time to time, it's interesting to have a look into the source code. Now on the side of Elasticsearch, every time there is text involved, we have what we call a pipeline of analyzers, which are actually processing a little bit the text. It's a little bit cut off. So here it would be the lowercase. So first thing we do putting everything on lowercase. Then we do a check on synonyms. We have a synonym list to expand the terms. And then there comes the specific part per country. But we basically have the stop word, so we remove all the words that actually don't bring any meaning to the phrase. Then for some languages like Arabic, we have the normalization or simplification of the language, which will remove also some parts that are not meaningful for the search. And then for all languages, this is a very important step, we have what we call the stemmer. And basically the stemming is reducing a word to its root version. So if it's a verb, we will remove the conjugation part. If it's a plural, we will remove that part as well. So it makes sure that we have the root version of the word, which will increase our chances of finding a hit in the database. Then after all of this, we have the n-gram, which basically is what will allow us to do partial matching on all of this. And finally, we will remove some duplicates. So after we do all of this, it can happen that we will have two similar words on the search. So we, in that case, we will remove it. Here we have a small example of how that will work. So you can see that lowercase will simply remove all the uppercase letters. Then we have the synonym, which will expand the jeans, for example, to jeans and denim. The stop words removal, in this case, will remove the for at the end, which are not very meaningful for the search part. And then we have the stemming that will remove the verb conjugation and the plural. So this would be an example of what would happen if you search for that. The text on top, we will look for this kind of text inside the database. Here, once again, a simplified version of our infrastructure. First point I would like to make is that we do have several clusters. Once again, thinking about scalability, we want to have the capacity of running several clusters at the same time. And at the moment, with the current scale that we have, 3 clusters was the right balance that we found. And for example, we have Nigeria in one, Kenya in another one, and Egypt and a couple more countries in a separate cluster. For us, it would be fairly easy to change this configuration. We would simply need to do some DNS changes, and we can point a country to any other cluster, or simply create a new one and move some countries there. So this is a reassurance that we have in terms of scalability, that we can always add more clusters. In the end, we could even have a single cluster per country. Then also these countries, the country's configuration was actually selected according to the time zones to make sure that we have less probability of having conflicts of campaigns for the same countries, which would cause an even bigger peak in terms of traffic. And then in terms of composition, we generally have a Kong layer working as an API gateway, which is where we will handle all the IP restrictions, API key validations, rate limiting if that's the case. So Kong will do all of that before we actually try to process the request. Then we have the Shrek layer, the application layer, which is connected to a single database. And this is an important point. We have a single Postgres database feeding all the clusters. And it's not a scalability concern, once again, because all the values are in memory. So we are only reading from the database on boot up and whenever there are changes. But it's an easy way for us to make sure that all countries can reuse the same configurations. So we only need to go to platform once, configure search ranking, for example, and it can be applied to all the countries at the same time. And Kafka is also centralized as well. It also has its own means of scaling without any need of multiple clusters here. And beneath the Shrek, then we have the Elasticsearch clusters, once again, 3 of them at the moment. And here important to mention that any of these layers, Kong, Shrek, and Elasticsearch, can at this moment scale horizontally. So we can simply add new instances, and we will be increasing the capacity of the system. Now, about the analytics feedback loop, which was a very important topic. These scores are coming from the data lake, according to the analytics data that was gathered before. And we can start with the product KPIs. So by looking at the impressions, clicks, add to carts, and transactions by product, we can actually try to infer the popularity that that product has, and that can be a very strong indicator of ranking for us. We should probably be showing the most popular products. If we have a product that has a lot of impressions but is never clicked, it means that product is not very meaningful for users, so we should not be boosting it. So we do have a lot of experiments around this, and this is the base data that the data scientists have, and then they compute a lot of scores to try to guess what is the popularity of the product. For example, at the moment we have more than 20 scores that try to represent the popularity of the product, and then we are constantly doing some tests with them on the system. Besides the product KPIs, we also have the seller KPIs, and here these ones are mainly focused on the quality scores of the seller. So we have a look into the return rate, the cancelled orders, all of those indicators that will tell us that the customer experience is not that good with that seller. And we will also try to make sure that these sellers will not have products on top of the search. So even if those products actually convert more, we know that they will bring a bad user experience, and products will be returned, orders cancelled, so we still try to manage that and deboost these kind of products. Important to notice here that we are also using here some time decay functions to make sure that this data we are considering at least 1 month of history, but we do give a lot more importance to yesterday and than we do for the last month. Another point in which the feedback loop from analytics was very important was the autocomplete, which at the moment our autocomplete is actually suggesting what we consider to be the best searches, both in terms of popularity and in terms of conversion. So once again, we are getting this from analytics, seeing which kind of searches people are making the most, which ones are most likely to translate into conversion, and these are the searches that we are trying to put in the autocomplete phase. Now, when it happens that we don't have any such search to suggest in the autocomplete, we will fall back to the catalog and simply have a look into the catalog what kind of products and text we have associated with it that we can actually suggest to the users. Now, having a look into the results, starting by scalability. In terms of assortment size, we actually already doubled the assortment size since we started the project. So once again, it was important to take this into consideration early on. And here, so at the moment, we are handling very well the scale, and we do know that even if this keeps growing, we will have the sharding capabilities of Elasticsearch to handle the big catalogs. So here, Elasticsearch has our back in terms of scalability for the catalog. Then in terms of traffic, as I mentioned on the infrastructure side, we do have horizontal scaling in all layers of our architecture. So this will also allow us to have a very big scalability. So we can increase the traffic, we simply need to spend a little bit more money and add more machines into the clusters that we have. Also important to take notice, it was an interesting improvement. The response times compared with Algolia actually decreased quite considerably, which also are a good indicator that we will be better prepared to handle an increase in traffic than we were before. And also in terms of scalability, it's also a lot easier now. So with Algolia, we need to do some kind of contract negotiation for scale-ups. That kind of thing, it could take a couple of days before we were able to scale up. And now, since it's an in-house system, we can scale up with a single click. In terms of experimentation, well, there was none in 2018, for example, before the project started. Now we generally have more than 180 tests every year. So this would mean that at least we are doing tests in the system, and if any test is bringing improvement, it's a win for us. So there was a big change here. And also we are actually empowering the search engineers, so they are now more independent to do their own tests without involving the development teams every time they want to change something. And now the big question, so is the search any better now than it was a couple of years before? And I will actually start with a disclaimer. So it's not a very hard, very easy thing to measure. It's not trivial at all. And especially trying to measure it over time. It can be a little bit misleading because we are not only evaluating the search itself, but we are also evaluating the quality of the catalog behind it, the price competitiveness of Jumia, and all of that at the same time. Still, what we have seen in the last couple of years is that multiple A/B tests have shown improvement. So in those cases, we know that with the same catalog, with the same prices, we have seen good improvements with the A/B tests that we then rolled out. So we are confident that there were several improvements that came purely from the search improvements that we did. With that in mind, we can start by having a look at the click-through rate, the CTR. This is simply taking all the clicks and dividing by the number of impressions. So it basically tells us the interest that the users have into what we are showing them, and what we have seen so far is a very consistent improvement. So since we started the project, we already doubled the rate of clicks for any impression that we would show the users. And in terms of conversion rate, so number of orders divided by impressions, it's very similar. So we have also been seeing a consistent improvement over time. And in this case, it's even slightly bigger, so 3 times better than it was a couple of years ago. Once again, I'm not saying this is only because of search, it's also because of the content that has been improving at Jumia, but overall, it's a great trend to look at. Now regarding the next steps, we do know that the journey has just started, so the search topic is a never-ending topic. We will be working in this forever, basically. And these are the main topics that we have already identified. One of them is what we call the active search management. So search engine would be giving the ability to manually tweak some searches. And this is very important because generally in any e-commerce, it's also the case with Jumia, there is a relatively small percentage of the queries that translate into a big percentage of the traffic. So these very important queries could be something that we can manually have a look at and try to improve and try to do specific A/B tests on to try to convert even more for those specific cases. So we want to build the tooling to allow the search engineers to go into this level of detail to bring some improvements. Another topic it's the offline tests. And A/B tests are great, but they do have a huge drawback, which is they are slow. So whenever we do an A/B test, it takes 1 to 2 weeks at least to gather enough data for us to be able to take a decision. So that's still a considerable lead time for us to get any feedback. And if we have hundreds of thousands of configurations settings that we want to have to test, it will be tricky to do all of them via A/B tests. So here we can try to do some offline testing in the lab, in which we can set up hundreds of configurations and test them in one click. And the other end is that we will need to rely on manual adjustments to that, so do some kind of manual annotation of how good is a product for a given search, so that then we can feed into the offline tests. Then as well in terms of personalization, so we already did a few developments on this topic, but there is still a lot to do in this and a lot to improve. So we do have the data, the categories, brands, and even operating systems, clothing size, all of that people are searching for and buying, actually. So we can use all that data to improve your search experience and try to boost all of these things. And then we can even be more ambitious and try to do it in real time. So all the searches you're doing could be gathered, and the next search you do could already be influenced by the last filter that you used. So you're looking for a phone, you filter for Android, you go back, and then our search would already try to boost the Android for you, because we know that you're looking for something in that spectrum. Also, data enrichment, it's an important topic for us. The search can only be as good as the catalog that we have, so we should always aim to improve it. And here we can assist the sellers into providing even better content quality and categorize their products a little bit better. But then we can also have some kind of clean and extraction methods to extract some more useful information from the data that we already have. And an example that we have been playing around with is image analysis, in which we can try to get some words from the images and apply the search on it itself. And lastly, we do want this to be the search for Jumia. So for now, it's only working on the Jumia marketplace, but we should now try to leverage the value of what we built here and do it even more generic. So we already have a schemaless solution. There is some work to be done there, but then any system from Jumia could actually reuse this search, and we would get a little bit closer to having a more uniform experience across all the Jumia platform. And that's all. Thank you. And we are hiring for a search team. So if you actually enjoyed what you saw and you think you would be a good contributor for this kind of teams, please reach me and then we can talk a little bit. And now I think we have some time for questions. So the question was, how do we divide the indexes in Elasticsearch, and what is the average chart size that we have? Okay, so at the moment we do have an index per country, for cattle, and the biggest one at the moment is Nigeria with 20 million products, and we are trying to aim at having like 10, 15 million products per chart. So at the moment, for example, Nigeria is actually running on 2 different charts. So it's already an example in which the scale of the catalog already needs for sharding, otherwise the response times will get too slow.
So what is the key for the sharding for the same code? What is the key that you are using for the
It's the product SKU.
for the code?
SKU, so it's an identifier of the product. So here the question is, how do we actually deal with the Arabic language? So the English one is a little bit easier to understand, at least for me. But so this is also something that we are getting from Elasticsearch. So Elasticsearch already has support for Arabic, and out of the box gives us support for the standing, for the normalization of Arabic, and we are leveraging that. To be honest, it's probably not as good as the English one. We have to dig a little bit deeper to find some good content. And then another tool that we have is the synonyms, which that one is managed by ourselves. And here we try to have the Egyptian team providing good synonyms for that.
Actually, I have a question.
Sorry. You want to go first? It's not that long.
So as far as I remember, diagram tokenizer is not the best recommended tokenizer for search, but I can see that you have chosen. So is there a specific reason why you're using diagram tokenizer?
Well, here we are using the Engram tokenizer to make sure that we can handle partial searches. So what the Engram does, it will break around your word so that we get all the smallest compositions and then do a search. So iPhone, we would get the I, then the IP, IPH, and so on and so on. If you simply use it blindly, it may not be very good because it will increase a lot your index size. Here we have studied it a little bit and tried to have, you can configure it so that it only starts from a certain range. So we are only starting from the second or third word so that we don't have too many data on the index.
When it comes to this legal system, we have like pipeline. We were talking about the system, and I was wondering if this part is like or is it like real-time
Okay, so here the question was about the analyzers that I showed, if they are running offline or running for every request that we receive, right? The search request process, okay. Okay, so we do try that as much as work as possible is done on product updates, so that searches are as fast as possible. But with that being said, there is still a lot of work that needs to be done in the search part. So all those analyzers that you saw actually run as well in the search part, because we need to decompose what people are searching for, and the personalization is the same thing. So we do try to keep in cache as much as possible. So if you make a request, we will try to get your personalization information and keep it in cache for as long as possible, so that through your session, we won't make multiple requests. Any other questions?
I have a question about the audit process. Linking the indexes of Elasticsearch. What is the frequency of updates with post-increase database?
Upgrade of the versions or
Of the data.
the data? Okay, so as I mentioned, we have more than 10 million product updates per day. So we do have a lot of updated information. We are using Kafka to work as an event stream to make sure that we don't overwhelm the database. So when there is like a very big seller that has like 1 million products and it does some kind of change that massively updates all these products, we may have a little bit of like 5-10 minutes there. But apart from that, it should be in real time.
Real time, there is no delay.
Yeah.
About A/B testing, are you doing A/B testing? Are you doing internal tool or external tool? And is that something that can be used by across all?
Not really. So here, who is doing the A/B testing? Sorry. So he's asking about the A/B testing part. How is it handled? If it's an external tool that can be used across other frameworks, and not really. So here, Shrek actually only receives the information about this user is on this A/B test or not, and then we do have all the configurations and we'll read them according to that. We are not the ones that are doing the division, like this user just got into the marketplace, so he's going to get assigned this A/B test. That part is being done by the marketplace itself. Right? Yeah.
I was asking why don't you use canary deployment so you can test the new feature on a percentage like 40% out of 100, so you can test it live and do the full deployment after this. This is one question. The other one is do you rely on a single cloud provider or it's hybrid cloud?
Okay, so the first question was if we are using any kind of general deployment to like only redirect some part of the traffic to it. We are not. Actually, the A/B tests are giving this kind of functionality a little bit for free, because we can go to the A/B test and say like this A/B test only for 10% of the users will go into this search configuration. So it ends up being some kind of canary testing there. And the second question was about the cloud provider. So at the moment we are using a single cloud provider, AWS, for this. Actually in a single region. This is also one of the things we want to work on. And it's actually not that hard considering the architecture we have. Shrek is actually able to work with multiple index clusters. So we can actually tell him that use this index cluster to write and read, and then duplicate all the information into another index Elasticsearch cluster in another region or even another cloud provider. So it would be feasible, still not implemented. Any more questions?
Yeah, I got for the users that does not have did not made an account yet, or you have like something that you can say. Because also is there any recommendation for them based on like previous search that they made without account?
So he's asking about users without an account, so we don't have any previous information for them. How the recommendations work? Here we have a fallback recommendation. So according to the generic traffic, we try to get a sense of what people are looking for the most, and we build up a set of fallback recommendations that are shown to anyone that doesn't have any background information.
Let's talk about if he made like some search and you can recommendations getting for the result based on this previous search without an account also, or should the user should have an account to get a recommendation based on this previous?
Okay. Yeah. So it's actually asking if you actually need to be logged into the system to get this kind of personalized content. And you know, so we are able to track you via the Google identifier, even if you're not logged in. If you do multiple requests, we're able to know that it's the same session and apply the recommendations then every time. Yeah.
Okay, so my question is, you were talking about the scaling, and for sure you pay more. So that's for sure like planned. If you have like a campaign or maybe in Black Friday, right? So it's we have to for sure that the variant of how much could we scale. But sometimes it's unexpected to have like a maybe unexpected traffic in the campaigns, right? So how do we deal with this?
Okay, so in terms of scaling, we are able to scale horizontally, as I already said, and we do have auto-scale configured. So if the CPU reaches a given target, we will automatically add more nodes. But as you saw on the campaign charts, they are very steep. So auto-scaling will certainly take like 5-10 minutes to actually build an entire Elasticsearch node with 20 million products to serve. So in those 10-20 minutes, what we have as a fallback is what we call the degraded mode, in which you can tweak around on the system to remove some nice features that we have but are not super essential, so that we can at least keep showing products even though they are not the best ranked or whatever. So we diminish a little bit the quality, but at least we still are showing products, which is the end thing. As soon as the nodes end up the scaling, then we can reactivate everything again.
Okay, so does it affect like maybe the caching? So you know, like the data is up to date, and we need to maybe take like 5 or 10 minutes. So it's like directly affected that kind of maybe searching while doing some caching layers or being up to date. But I mean, the part of consistency and so.
Okay. So in terms of caching, we have all the caching configurable in the system as well in real time, and we do have very different configurations. There is some information that is very heavy to compute and doesn't change that much, like the facet count. How many products you have in a given category doesn't change that quick, so that information we cache more aggressively. The products themselves, we don't even cache them because they can be updated in real time. That what we can also do when we have very big campaigns is adjust a little bit the cache levels, and if we are running into trouble, we can be a little bit more aggressive with the caches that we have.
I don't have such lag between the search results and whatever. Like if we have any updates, so we can expect some lag, like in seconds, minutes, so.
Yes, in worst case scenario, 5 minutes. Any more questions? No?
Okay, I think.
Feel free to reach if you have any more questions.